So typically the very first thing that a person will think about when they're trying to describe or understand the actual layout of a Latin square design is a Sudoku table. So as you see, Sudoku follows the basic premise that you can't repeat numbers in the same columns, rows, or larger outline squares. And we see that it's a 9 by 9 plot, and therefore there's 81 total numbers, which means that there are 9 of each number ranging from 1 to 9 within any one given Sudoku square, which is kind of similar to that which we'll see in the next slide of a Latin square design. A Latin square design is a statistical tool that allows us to consider three factors, of which two are blocking factors or sources of variability. So the idea is that they allow us to control these extraneous sources of variability in an experiment in order to analyze our treatments with the least amount of error. So take an example of, say, cooking pasta. A reasonable person can agree that pasta will come out differently, whether that be flavor, tenderness, or shape, depending on the pot that was used, the type of oven it was cooked in, and the process used to actually cook the pasta. Therefore, in this experiment that you can see, our two blocking factors are the pot and the oven. So we want to analyze the cooking process as our treatment. Thus, the pots are in the columns, the ovens are our rows, and the processes are inside the table as our treatments. Putting this into a little bit more of a practical application, or say an engineering application, we can actually look at the Latin square design and its use in terms of determining the life expectancy of a battery. So if you were talking about a battery, we would need to be looking at things such as the actual phone that's being used, such as those provided in this example, so Apple, Android, Google, Huawei, whatever it might be. And then the operating system of the phone would also be another blocking factor that would determine how much the battery depletes over a course of time. So we have just generically operating system 1, 2, 3, and 4. Those could be anything from an Apple operating system, an Android operating system, Google, whatever it might be. And the treatments inside of here, or the things we're actually analyzing, is the battery itself. So the kinds of batteries that are being used inside of these phones, and then it would be determining inside as well the amount of time or the battery life that actually exists after this phone has been on, used, or otherwise. So once you have all your data assembled inside one of these other tables, once you actually have the practical application and you are applying it, then you can actually go ahead and turn all this data around, put it in a ANOVA table, and an ANOVA table inherently allows you to make the analysis of all of your data a little bit easier, and it allows you to support some of your calculations, get these mean sums of squares, and get the averages and different values necessary to understand